It's a beautiful day to make horsepower. It's a beautiful day to make torque to would you be mine? Could you be my engine builder, that is. I have an awesome announcement today that the JRE, these folks down in Australia, they dynoed a 500 cubic inch small block Chevy for us, and the results are in. I can't say without enough emphasis how excited I am, not only to show you the dyno results, but to show you the official Mr. Rogers cardigan sweater as I make this announcement. So Mr. Josiah, here's to you, bud, for the cardigan recommendation. I really like it. Anyway, so Jerry, I'm going to disclose the full disclosure on the dyno results. I will get to that to you. I promise you that will be in this video. You might have to watch a lot of it, but there's a lot of important stuff that I want to talk about in this video right now about the design process, working with JRE, some of the concepts that went into actually building an effective jet sprint NA monster like the guys down there at JRE did. So I hope you enjoy this video. I can't wait to tell everybody what it did. Brad and I talked about, hey, do I share all my secrets? I don't care. If somebody else wants to go build the same motor and come get me, come and get me. So there's no secrets here, but I'm super stoked to be promoting JRE and the work that they did. It's been an awesome build process, so I hope you enjoy this video. All right, so that first dyno pull, Brad was working on some issues between the left and the right banks that he said that he was getting a lambda split between those two, and it was kind of frustrating him. I could tell in his messages that he was kind of struggling with that a little bit. Lo and behold, he kind of came to find out that the computer or the box that he was using, brand new out of the box, wasn't working right. So a quick swap out of those and he got it to work right. So if you listen very carefully in that first run there, he was not getting full RPM. So the later one I'll show you here in a bit, he does get full RPMs, and that's what the dyno graphs were. But anyway, he was struggling a little bit with the dyno. So let's back way up to when I first contacted Brad about doing a big cubic inch small block build for one of these jet sprints. I wanted instant acceleration. In order to have that, you have to have a big, wide, flat torque curve. So I talked to Brad a little bit about this just the other day before I putting this video together. If I could get his input on like why is torque so important on a jet sprint boat, and he agreed with me that you do want that torque curve all the way from essentially idle all the way to your max, and our max in these things is about 6,600 RPMs. What happens once you get above that? You're, say at 6,000 RPMs, you're shooting a column of water that big around out the back of the boat, and that is pure acceleration because that water has a mass and a weight to it. If you spin your impellers beyond that, you actually start boiling the water on the backside of those impellers, and that is actually what you refer to as cavitation. That is cavitation. When you're going around a corner and your pump grabs air, that is called aeration. So if you spin these things up over 6,600 RPMs, you're going to start to cavitate, and you're going to literally boil the water, and you're going to be shooting out foam, partial foam out the back, and you're losing efficiency of the pump. So we target 64 to 6,600 RPMs right there. So that's a big difference in a sprint car engine. Those things are usually targeting up in the 8,000 RPM range or so. But Brad did say that there is a ton of similarities between a sprint car engine and these sprint boat engines. So I'm going to show you, here's going to be the time lapse of Brad putting this thing together. I'm going to talk a little bit about the parts. It's a CN billet block. We have Gibb Tech pistons. We have a Bryant lightweight crank, Oliver Conrods. The other thing that he used the bigger diameter full half-inch push rods in there. So that delayed the final assembly a little bit. The heads are monsters, and he showed me the flow sheets, and man, those things move some air like you read about. So that's honestly where your power comes from. So that is the basics of this thing. We went all out on this this design, and it was Brad's design from the day one. He says, hey, I have a 500 in my head that I'd like to build for a sprint boat, and that's kind of got us starting. So you can see him building this thing, putting it together. Nothing but good things to say about his office. It looks like a doctor's office. It's so clean in his assembly room. Immediately covers it up with plastic, so he's not getting any you know, dirt or anything in there, debris in the build process. So why did we go mechanical injection on that? So backing up, we did approach Engeler and their timeline and their cost to do it's essentially a full custom designed mechanical injection system for this motor. It was cost prohibitive and time prohibitive. So we went with Engeler, which is just as good. It's kind of the Ford versus Chevy or Dodge. It's all, the concepts are all the same, and we're super happy with Engeler. Brad did do a 3D printout of the essentially the valve angle and everything, or the head angle and the manifold angle for those things, printed out a 3D thing, sent it, make sure it fit right, and then sent those drawings to Engeler, and lo and behold, now we have an absolute awesome Engeler injection system, and I can't wait to let this thing rip. Anyway, so moving on into the dyno. So let's talk about the numbers first, and then I'll let you hear the hard pull where we got those numbers. So, drum roll please, we got 1,032 horsepower out of this monster. And the day that Brad tested this, he said it was over 100 degrees Fahrenheit in Australia where the shop is. And his dyno does a correction for those temperatures, and he said he has no doubt that we're probably actually closer to about 1,050 horsepower because his dyno does too much of a correction, or not enough of a correction, if you will. And when he's seen that in the past, when it adds that temperature correction, it doesn't get it right. So he thinks we're actually probably close to 1,050 on a normal 70 or 80 degree day. So 1,032 horsepower on a 100 degree day. So pretty happy with that, again, with the dyno correction in there. Here we are, excited about the horsepower numbers, but torque is everything in these sprint boats, and you got to have high torque from the beginning all the way to the end of that RPM range. So we're targeting literally from off the idle stops all the way to that 6,600. You want a nice flat torque curve. So here's the torque curve, the horsepower and torque curve. See that the horsepower, it's on that steady climb all the way across that torque curve, and it never falls off. And that's what's awesome about the results of this thing. The torque, it doesn't even start to take a dip until the very end, right at our target, about 6,500 RPMs is when it starts to drop. So the table here that I'm going to show you, that showed us, I think it was 858 or 868. We'll just say 850 foot-pounds flat across there. But he got it to peak at 870 foot-pounds, which is right where we wanted it to be. And he said he did that with just by having essentially a little bit cooler water going through it. When the water temperature started to build, he lost a little bit of that torque. So we're going to say 870 foot-pounds of torque, 1,032 horsepower out of the JRE 500 cubic inch Billet small block Chevy. Can't wait to put this thing in the boat. Can't wait to get it here to actually see it for myself with my own eyes here at my shop in Arlington. So can't wait to show the world this thing, get it in a boat, and let it start ripping around. Thanks for watching. Hope you enjoyed the video.